Assalamualaikum, dear students. Today we are going to learn what is meant by probability and how to calculate the probability of simple events. Bismillah Rahman Rahim. The topic is taken from the chapter number 13. Probability stands for this becomes equals to three word use in a common language that is called chance. तो चांस के बारे में मैकेनिकली कैलकुलेशंस को अंडरस्टैंड करना and to predict about an event before it's happening, to discuss its chance. This is called the probability. So the formula to find the probability is simple. So let me explain you that how do we form it actually, and how does it work. So the formula is basically to finding any event. Event means any experimentation. Like for example, we set an example to explain the concept of probability. So let's suppose if we toss a coin, then a coin can there can be two possibilities, which we will write it in a set which is called a sample space. So either a head can occur or a tail can occur. Nothing else can is possible. Now, if you want to find the probability, which is symbolically written as P, the probability of getting head in a single toss of a coin means if it is required. So we will write that how many number of elements are there in the sample space. Like you can see that head and tail, there are only two possibilities which can occur. So there are two possibilities which we have just counted the number of possible outcomes from the sample space. And then we have to see that how many are in the favor. Let's suppose we say that H is the event. H is the event that had appears. So in this set, you will see that how many favorable outcomes are there in the sample space for head. So there is only one. So you can write here that the possibility of getting head in the sample space is only one. Now, if you want to find the probability of head, so probability of getting head. So probability of getting head means a favorable outcome of head, favorable outcome of head, and we divide it by all possible outcomes in this experiment. So favorable outcome is one and all possible are two. So probability of getting head in one toss of a coin is 1 by 2. Similarly, you can also see that if you want to find the probability of tail, again you will see by using the same formula, there is only one outcome that is in the favor of tail. And if we divide it by all possible outcomes in the tossing of coin, that is 2. So the probability of head and tail both are equal, that is 1 by 2. Okay, we will take another example. For example, if we have a dice rolling a dice, and we want to find the probability, or we will first write the sample space at all possible outcomes in rolling a dice. For example, there are six sides of a die. So one, two, three, four, five, six, and seven. Seven, rather six only. So there can be only six outcomes if we want to roll a die. Now, if we want to find the probability of, let's suppose, even number appears on die, so we will see that how many points are there in the favor of even numbers. So 2, 4, 6. There are the three events in the favor of even numbers, and all possible there are six. So 3 by 6 means 1 by 2 will be the probability of even number. Similarly, if you want to find the probability of 5 only, then how many points are there in the favor of 5? Only one. And all possible outcomes are 6. So probability of getting 5 will be 1 by 6. If you want to find the probability of a prime number appears, so prime numbers are 2, 3, and 5. So in the sample space, prime numbers are 2, 3, and 5. So there will be again 3 points in the favor of prime numbers out of 6. If you simplify it again, its probability will become 1 by 2. So I have given you the two examples just to give you some idea that how we will be able to find the probability of simple events like this one. Okay, now we will be studying a little bit part of the theory or the definitions of probability. Quickly from the textbook, I have written it on the slide so that you people can easily understand and see. So the first line is the probability, the chance of occurrence of a particular event. Probability is calculated by using the formula. So the formula is, again, I have just explained you a moment before that it is about probability of an event is number of favorable outcomes in an for an event divided by total number of possible outcomes. You simply need to divide them together, and let's suppose if A is an event, then the probability of an event is A. Then and there are n of A means if you count how many favorable points are there, so number of favorable outcomes are written as n of A. So the probabilities will be written as probability of A is equals to number of favorable outcomes of A divided by favorable outcomes, all possible outcomes in the experimentation. So N of S stands for all possible outcomes. Then the basic concept of probability is like experiments, like we use the word experiment for each question. What is meant by the word experiment? So the process which generate results. For example, tossing of a coin, rolling a dice, etc. is called an experiment. So, and what is requirement? Outcomes means whenever we will be performing an experiment, there will be some outcomes after the experiment. There will be some results coming out of the experiment. The result of an experiment are called outcomes. For example, possible outcomes of a tossing a coin are head or a tail, and the possible outcomes of rolling a dice are 1, 2, 3, 4, 5, or 6. And now we have a proper definition for the favorable outcomes. An outcome which represents how many times we expect the things to be happened. So while tossing a coin, there is one favorable outcome of getting head or tail. While rolling a dice, there are three favorable outcomes of getting multiples of two from number 1, 2, 3, 4. 5 and 6. You will be seeing if you want to find multiple of 2, so there will be three numbers like 2, 4, and 6. And very important definition which will be used in every part of the probability, that is a sample space. So it is basically the set of all possible outcomes of an experiment. This is called a sample space, denoted by S. So an example is set there, like I have written earlier, that while tossing a coin, the sample space will be head and tail. It will be a set which containing head and tail. While rolling a dice, the sample space will be 1, 2, 3, 4, 5, 6, means all possible outcomes of a for this experiment. We also want to clarify that right now we are discussing the probability, and in sample space there may be some repetition of some numbers or some alphabets, although we are not strictly studying this topic of sets here, because in by definition, in case of sets, we do not repeat any alphabet or number in within the brackets of sets. But because we are typically studying probability now, so that means that there you can see that there are chances that in some questions we will be writing some repeated letters or some repeated uh, numbers, just for the sake of the understanding. So next is uh, I have to explain the concept of sample space of two dice. And we will also see that the probability of for any experiment, it will be ranging from 0 to 1. So maximum probability or the maximum chance of getting something happened will be equals to 1. So the range of the probability is very clearly separately mentioned in your book as well, and in the points as well, that what is meant by this range. Maximum chance of occurrence of an event can be 1, and minimum chance or the least probability can be 0. So it can't be negative, it can't be greater than 1. Now we are going to discuss quickly about that what is meant by sample space. So we will see that if we have two dice, right? So you can say the dice 1 and the dice 2. So dice 2, we join them together, or if we roll the two dice together on a table, and each die contains six sides containing the number 1, 2, 3, 4, 5, and 6, and another die will be 1, 2, 3, 4, 5, 6, like this one. Then if we collect the possible outcomes, that 1 and 1 both appear on can appear on both the dice. Then if we keep on pairing the numbers, that on die number 2 there is 1, and die number second die contains 1. So by pairing the numbers 1 and 2, 1 and 3, 1 and 4, 1, 5, 1, 6. So this is basically the possible outcomes uh, for rolling two dice together. So maximum there can be 36 possible outcomes, like 6 into 6, because there are six sides of each dice. So all possible outcomes are written here. So the students need to do the practice of them, because the questions come right directly about the rolling of two dice. And then we so in the onward questions there are multiple type of things that can be asked, but in particular in the next see that there will be the sum of the faces, means 1 and 1 altogether will become 2 by adding together 2, 3, 4, 5. We are adding the numbers which are which might come on the within the sample space. So either the sum, we want to find the sum of the faces, because the table is about sample space of two dice. So right now all possible outcomes are there from die number 1 and die number 2, but we will see that in the upcoming questions we will be asked to find the different sum of faces. So how to find sum of faces? That first we will make the sample space of two dice, then right below it you will be adding the numbers, like 1, 5, 1, 6, it will become 7. Then again you will start from second row, 2 plus 1 will become 3, 4, 5, 6, 7, 8, and next in the third row it will be 4, 5, 6, 7, 8, and 9. What I'm doing, simply A student should be able to make this sample space of two dice, then they should make the sum of each of this possible outcome. So the questions will be related to these sums or ETCs like this one. So we have already done one table. In the next slide I will share with you, that is all about sum of faces. So for the sum of faces, obviously all these things, the sample space of two dice should be present there. So student need to do the practice. It hardly takes a minute to quickly draw all these possible outcomes of two dice. So again, the same thing is there. Wait a second. So for the sum of faces of a sample space of two dice, where I have a proper slide to explain this concept, that if the sum of faces is mentioned right below here at this position, this is die number one. This is in downward direction, and die number two is from moving from left to right. And then the sums are been there. So sum means that like one plus one was two in the above, two, three, four, five. So similarly, directly sums are written here. Two, three, four, five. The same I explained earlier. Sum of faces are separately done. So this is called a table consisting of sum of faces of sample space of two dice. So maximum sum 6 plus 6 can become 12. So this 12 is mentioned right here. This is how you have to make it quickly, and you need to explain it like this one. So similarly, students, that as we have calculated earlier, the sum of the faces. Similarly, we also need to find product of faces and difference of faces. So I have made separate tables for product and sum of faces, but quickly I want to explain here that how we will be able to find the product of the faces. So product of faces means that we should have the sample space of two dice, and you just need to multiply these two numbers. So 1 into 1 will become 1, 1 into 2 will become 2, 1 into 3 will be 3, 1 into 4, 1 into 5, 1 into 6. Similarly, 2 into 6 will become 12, 10, 8, 6, 4, 2, and the largest one will be 6 into 6, 36. So the product of faces will be starting from 1 till maximum 6 into 6, 36 can be there. So this is how we will be making a table consisting of a product of faces. Means the faces we should have a sample space consisting of uh, faces of two dice, all possible outcomes, and then we will need to quickly multiply them together to find the product. Similarly, if I would like to explain how to find a difference of a table. So difference of faces. So difference of faces means that you just need to do the subtraction between the two possible outcomes, and the rule of difference will be larger minus smaller in each outcome. For example, 1 minus 1 will give you the difference of 0. 1 comma 2 means 2 minus 1. Larger is 2 and 1 is smaller, so we will do the difference. 2 minus 1 means 1. Then difference will be 2. Difference will be 3. 1 minus 5 minus 1 will be 4, and 6 minus 1 will be 5, and so on like this one. So in this table we will notice that the largest difference can be 6 minus 1, that is 5. And if we move to the last row, 6 minus 6 will be 0. So 1, 6 minus 5, 2, this is 3, 6 minus 2 will be 4, 6 minus 1 will be 5. So similarly, I have a particular table that is indicating that what will be the results of difference of outcomes. So I'm just going to share you on the slide now. I have just explained you that how to make quickly the table of product of faces or another table that is about the difference of faces. This is the table I just have explained you. This is about difference of faces. Means if the students uh, should first learn or the practice a sample space of two dice, as you can see that, and then their outcomes are used either for sum of faces, their product of faces, or difference of faces. So all three tables are there, and then the relevant questions will be there. I'm just going to indicate you, or I'm going to show you now what is indicated over there. So this is the table sum of faces I have just explained you earlier. Similarly, the product of two dice and the difference of two dice. So as I just explained earlier that by writing with my own hands, that how the product of faces comes and how the difference of faces of two dice are can be written as. So it is the same concept, same numbers, but you need to have this table, that is all possible outcomes, in a first go, and then you can find some product difference according to the requirement of the questions. So now we are directly going towards a question that is from exercise 13.1. Question number one. The question is exactly taken from the textbook, and it is written that Arshad rolls a dice with with sides labeled L, M, N, O, P, U. What is the probability that the dice lands on the consonant? So we have to understand that when dice is rolled, the sample space will be L, M, N, O, P, U, because this time uh, dice contains alphabets L, M, N, O, P, U, not the numbers. So as it is mentioned in the question, so what possible can come out from this experiment, that is written in the sample space, that is S. So S is written as sample space. So possible outcomes are L, M, N, O, P, U. So there are six possible outcomes because they're the six sides of the dice, and it contains these six letters. So we've been asked to find in the question, find the probability that it provides a consonant. So we have to keep the difference in mind that the vowels are normally, you people remember that vowels are A, E, I, O, U. These are the five letters which are considered as vowels, and the remaining alphabets are considered as consonants. So the opposite of vowel are called consonants. So you will see that I have written let A be the event of getting consonant. So A is basically a set, you can say a subset or a smaller set of the sample space that contains consonants only. That L, M, N, P, I have taken this from the sample space. So in the favor of consonants, there are 4 points. So by rule of probability, as I explained you earlier, the probability of getting consonants, that is event A, is equals to 4 over 6. So 4 over 6 means there are 4 points in the favor of consonants out of total, that is 6. So you can also say that the probability of this event is like this one, n of A, or divided by number of sample space points. So as 4 over 6, so simplification will return you 2 by 3. This is how you can work out the first question. And now we move to the quickly to the second question. So first one is quite simple. Okay, the question number two is about Shazia throws a pair of the fair dice, means two dice are thrown together. What will be the probability of getting sum of dots or the sum of faces at least four? So in this question, I have done two tasks in parallel. Like if I enlarge it, we can understand in a better way. Okay. So for this part, I have made one. original table of sample space, you can see here at this position. Actually, we need for the sum of faces only. So, but for your convenience, I also have taken the sample space of two dice in front of you or on the slide, so that we can see that first of all you need to make this table as I explained you earlier, sum of faces of two dice, and then all possible outcomes of two sample spaces. Then the sum of faces is written as the sum of their faces, like 2, 3, 4, 5, and so on. So this is directly written in this format, like starting from here 2, 3, 4, 5. So actual requirement for this part of the question is about sum of faces only, and it has been asked in the question that find the probability that sum of dots is at least 4. So technically we should first understand that what is meant by at least 4 means. So at least 4 means that the sum is 4 and above, right? Means that at least stands for minimum, means it is a lower bound. You can go from 4 and above. That is meaning of at least 4. So if you look into the table, so the table shows that sum is 4 and more than 4. If I draw it at the diagonal positions, you will see this side all these four numbers. There are four. And then next is sum is more than 4. That is 5. Then the sum is 6. This is all the numbers, all such numbers which are greater than 4, thus making sum greater than 4. Like this one. All these numbers are all these sums are such numbers which are making a sum greater than or equal to 4. So if we count all these numbers, you will notice that only three numbers cannot be included in this experiment, uh, whose sum is less than 4, because our requirement in this question is that we should have number 4 and greater than 4. So sum of 2, 3, this will not be included. So now, because altogether in the favor of sum 4 and greater than 4, there are 33 points from the sample space, because altogether there are 36. So only 3 points are there which are making sum less than 4. So those will not be included. So that's why I have written there are only 3 outcomes where sum of dots is less than 4. So there are 33 outcomes where sum of dots is either 4 or more than 4. I have just explained by drawing diagonal lines in the table. So there are 33 outcomes in the favor of sum 4 or greater than 4. So probability of the event will be 33 over all possible outcome, that is 36. Simplification, this like this one, 3 ones are, 3 ones are, 3 ones are, 3 twos are. So it will be returning probability 11 over 12. So simply the question is done. This is how you need to work out the question. This is question number 2 and its first part is done. Then we have another part, that is a very next one. It is about product of both dots is between 5 to 10. I have included the one word inclusive in it, because if I do not include this word inclusive, it causes a problem. So the word inclusive should be there, because the concept of between 5 to 10 is that 5 and 10 will not be there. Means that we will count the number from 6, 7, 8, 9, not 5 and 10. Endpoints will not be included. So, but the book has taken it as like they have included it. So that's why, uh, just a moment. So 5, 6, 7, 8, 9, and 10. So normally between means that we want to count the numbers in between 5 and 10. 5 and 10 will not be included. So if you want to count the number including the endpoint 5 and 10, then the word should be product of both dots is between 5 to 10 inclusive. So the one word I have added myself. I hope that this will give you the difference. If we want to find the number between 5 to 10, then 5 and 10 cannot be included. So the word inclusive should be there. Now come to the question that what is written. We first need the product of both the dots. So just to give you this concept, I have done that. I have pasted first at first place the all possible outcomes of two sample dice. Then the product of faces is taken. So 1 into 1 is 1, 1 into 2 is 2, and 1 into 3 is 3. So all this product is, you can see that I have separately pasted the table which is indicating product of faces of two dice. So the product, right, as mentioned, I earlier mentioned on the above table, in the actual table is which is required for this part is about product of faces of two dice. So because you are the new learner, so that's why I have done both on this slide, that I have pasted all possible outcomes of two sample dice, and below is the product of faces as well. So we need to find the product is very clearly written. 1 into 1 is 1, 1 into 2 is 2, and then so on all together. So if you just need to find that how many numbers are there between 5 to 10 inclusive, mean that you just need to count that how many numbers are there including 5 till 10. So if we just count the numbers from this table, you will see that 5 is right here. So this is the first number, 5, 6, 10, 6, 10, 12. Sorry, 10, 12 cannot be there. Uh, Again 6, 9, 8, 5, 10, and 6 again. So if we just count that all these are numbers lying between 5 to 10 inclusive. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. One more number is there. I think probably I have also separated the numbers which will be in this favor. So if we start counting from here, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So 11 such numbers are there which are making a product 5, 5 to 10. So there are 11 outcomes I have mentioned right here. So 11 over 36 is the basically probability of finding. This is the probability of I need to write it here. Probability. So probability of I have declared the event that B be an event of getting product of dots from 5 to 10 inclusive, and consequently I am getting the probability. So I hope that uh, you will be able to understand the question. So the 11 outcomes were there in the table. Now you can see that those are all marked. And finally, simply you write to mention probability. You can go both ways. The easiest one is that you should make the product of faces of two dice. And an alternative is that if you are expert enough, then you can make this sample space, this subset of product from the sample spaces. That would be making product 5 uh, to 10. We have a third part that states it's about difference of faces. And similarly, again, I have pasted everywhere the actual sum of faces, actual sample space of two dice. And then right below is a difference of faces, because in this question is about the difference between both the dots is equals to 4. So first we need to make a table or a set. I think the table will be more important, because visually you will be able to see all possible outcomes. So this is a table that contains difference of faces, as I have explained earlier, that how to make the difference. So 1 minus 1 will become 0, 2 minus 1 will become 1, and 3 minus 1 will become 2, and so on. So exact table is right below, which will be used for the difference of faces of two dice. Now the question is asking that the difference is equals to 4. So you just need to find that how many possible differences of 4 is exactly in the table. So this is 4, 4, right here it is 4, and one more thing is it is 4 also. So altogether there are probability of getting difference of 4 is like 4 out of 36, because altogether there are 36 outcomes. So 4 over 36, after cancellation it will become 4 by 9. Which the next part of this question is that we have to see number at least 5 on first dice. Means that the first die is actually, I have drawn it right here. This is the dice number 1, and it should be, number on dice should be at least 5, means that we will notice from 5 and 6 columns. This is a die number 1, for example, and number is 5 and greater than 5. That will make the sense for 5 and 6. Similarly, for the second die, the number is should be at least 4 on the second row. So number should be 4. So you will see that in the second die, right here, the number is starting from 4, 5, 6. So now we've been asked, actually the required result is that if I make a separation, that for the die number 1 we should have all these possible outcomes, all these possible outcomes. So they, for die number 1, so there should be, number should be 5 or 6. In this box you will see that all the numbers which are greater than 5 or 6 are mentioned in each order pair, as you can see that in all these numbers for the die number 1. At the same time, for the second die, we will see that we are asked to find that we have to keep the number at least 4. So by doing it like this one, you can see in the blue box, highlighted box, which is indicating that for the it contains all possible subsets or all possible outcomes in which second die contains the number at least 4. So all such numbers are there. So in the question, in fact, it has been asked one important word which is very which important to understand, that the word and is used. So in case of finding probability, if and is used, then we have to see that we want to find what is common between the two events. Like for example, you will see it is written that E be an event getting at least 5 on the first, and at least 4 on the second dice. So we want to collect it actually such points in which both of these characters are merged. So you will see here that in this part, which is a common part of both the cases, I just want to highlight like in this position. You will see that in this green box, all such properties are merged together. Means we have separated first 5 and 6 for the die number 1, and for the second die we have separated 4, 5, 6. But in this green box, which is a common or an intersection part of both of these concepts, it contains these 6 such numbers विच आर सच के इसमें जो पहले वाला नंबर है लाइक सब में एक डाई के अंदर वो 5 या 6 वाला है, राइट, और जो सेकंड वाला नंबर है वो 4 या 4 से बड़े वाला नंबर है लाइक दिस वन, ठीक है, यू कैन सी दैट इट्स ऑल अबाउट दिस वन. So you just need to separate the terms from the table and then you just write it separately. इस तरह के फेवरेबल आउट पॉइंट्स जो हैं वो 6 हैं, ऑल टोटल 36 हैं. जब आप प्रोबेबिलिटी इस इवेंट की लिखेंगे सो दैट विल बी 6 आउट ऑफ 36, सो आंसर विल बी 1 आउट ऑफ 6. तो ये इंपॉर्टेंट कैरेक्टर है. जब एंड का वर्ड आएगा प्रोबेबिलिटी के अंदर तो उस वक्त हम वो दो केसेस आपको देता है और उसमें जहां एंड का वर्ड आएगा उसमें आपको कॉमन पार्ट देखना है, जो दोनों करैक्टर्स का कॉमन पार्ट है उसको लेना है. आगे जब हम देखेंगे क्वेश्चंस में कहीं पर ओवर और आएगा तो वहां पर वी विल बी टेकिंग ऑल पॉइंट्स, हमें वहां पर सबको यूनियन करना पड़ेगा. एंड के केस में हमें इंटरसेक्शन या कॉमन पार्ट की तरफ जाना होता है, और के साथ अगर आएगी प्रोबेबिलिटी फाइंड करनी तो वहां हमने यूनियन करना है, सबको मिला के फिर उसकी फेवरेबल आउटकम्स बनती हैं. जब आगे क्वेश्चन आएगा आई विल एक्सप्लेन यू फर्दर. बाकी क्वेश्चन जो है वो सेकंड वीडियो के अंदर है बिकॉज इसके अपने इतने सारे पार्ट्स है, तो आई हैव डन इट विद इंट्रोडक्शन. You will see the second video in which the remaining part of this exercise are been done. Those are comparatively shorter than these 4 5 parts.